One, thank you. Hello, everyone. Thank you for being on time to come today. I'm Claire from the Overseas Technical Support Team of Dubot. Welcome to the Industrial Cobots online course. Here with me is Hans. Let's make a little interaction now. If I have made myself clear, please type clear in the chat window to let me know. Okay, thank you. To notice is that during the course, you may type your questions in the chat area and my teammate Hans will answer them live. Also, after completing one or two parts, we will arrange a Q&A part. Another thing is that due to the quality limit of the video online meeting, there's a signal delay of around 5 seconds. Thanks for your understanding. Okay, firstly, a brief introduction about Dubot. Dubot is a world-leading provider of intelligent robotic arms. Our solution seamlessly integrates AI-powered lightweight robotic arms and proprietary software suites. By replacing traditional manufacturing processes with advanced human-machine collaboration models, Dubot meets the demands of flexible production and will be the standard of tomorrow's smart production process. The core function training of the MG400 is divided into 6 parts. I want to begin with introduction, and I will move on to point-to-point motions and complete trajectory motions. Next, we are talking about palletizing, remote control, and appendix. Okay, let's start with the MG400 introduction. There are several features of Dubot MG400. It's a space-saving lightweight desktop robot with an occupied space less than a piece of A4 paper. It has 4 axes and multi-programming options, which is simple to use. So it's definitely ideal for tasks such as repeating lightweight tasks, automated workbench scenarios, like visual sorting, glue dispensing, loading and unloading, etc. The maximum distance it can reach is 440 millimeters, and the repeatability is 0.05 millimeters. It occupied 190 square millimeters. For users with different technical ability levels, we provide different programming methods suitable for beginners and professionals with different programming abilities, including trajectory reproduction, graphical programming, and dual scripts. About trajectory reproduction, users can directly teach the robot the required moving trajectory, and then the robot can reproduce it. It's straightforward and much easier for programming novices to get started. The second one is graphical programming. Basically, by dragging the blocks, users can complete the programming just as easy as play a block puzzle. So it's really easy to learn and flexible. It requires a little programming background. The last one is dual script, which is perfect for professionals programmers. It's flexible and efficient and ideal for complete tasks. MG400 can also detect collision with precision. The collision force threshold is less than 12 Newton, which ensures the safety for man-machine collaboration. It's designed with 5 grades of detection sensitivities for different needs. MG400 can also suppress the vibration. We have increased the stabilization time by 60% and decreased residual vibration by 70%. It also has true motion dynamic algorithm, which ensures the high accuracy trajectory. Now, I would like to turn to the technical specifications of MG400. As I mentioned before, the repeatability is 0.05 millimeter, which reaches the industrial level, and the maximum distance it can reach is 440 millimeters. The rated load is 500 grams and maximum load is 750 grams. The joint speed up to 300 degrees per second. To get more detailed information, we could refer to this table, which illustrates the repeatability, joint range, power, weight, voltage, etc. Now, let's look at the application. Let's look at this video so we could have a more concrete conception for the MG400. Installation and connection. Here is a packing list of MG400. We can check our products with this list. So it contains MG400, Ethernet cable, zero position fixture, suction cap, flange adapter, emergency stop, quick start, power adapter, and some accessories. It should be emphasized that there are two nodes before mounting the robot. Design the mounting platform based on the robot's workspace so that the robot can move freely without interference with other objects. And please make sure the mounting platform is always level. Here is a detailed description of each interface. This is the encoder interface, which is for connecting to the conveyor belt for dynamic tracking. And this is power switch, emergency stop interface, power interface, I/O interface, air interface. There are two LAN interface and two USB interface. It should be emphasized that the default IP address of LAN 1 is 192.168.1.6, which cannot be modified. It can be used for software debugging on the Apple computer, while the IP address of LAN 2 is the default IP address of LAN 2 is 192.168.2.6, which can be modified. This is the encoder interface and wiring description. This is diagram illustrates emergency stop wiring. Okay, here shows the cable connection steps. The first step is to connect the emergency stop switch cable and then connect the power cable, the network cable, and then power on the robot. There are two nodes. Users should connect DC power of robot before connecting AC main power. And after the emergency stop has been triggered, rotate it counterclockwise to reset the button. There are three interfaces on the forearm of the robot. The first one is hand touch button. So after pressing this button, the users can obtain the points coordinate any point we want by dragging it to this point, and the robot will record the coordinates automatically. And the second one is end effector. The third one is air interface. We need to change the IP address before we connect the robot. So we can find the IP address here in Ethernet, properties, and change it to the numbers as shown in the picture. Then click OK. We can also distinguish the state of the machine by observing the color of indicator light. If the white light is blinking, means the system is booting. And if the blue light is blinking, means that the hand is under the hand teach mode. And if the blue light is staying on, means the system is started with servo disabled. And if the green light is blinking, means it's running a program. If the green light is steady on, means the server is enabled without running program. The red light means there are alarm status. I'd now like to move on to the next part, point-to-point motion. In this section, I will introduce you to a few common instructions. We are going to mention the following content: software instruction, introduction, new scripting projects, basic motion commands, basic programming control commands, and how to use I/O. Okay, this is the software interface, and here is the setting menu, the home page, and robot connection status, alarm log, enable switch, global speed, and emergency stop. There are 4 functions of the robot. And we can open the recent project here. Click to connect. In the menu, we can open the security setting here. There are 5 rates sensitivities. The collision force threshold is less than 12 Newton. That's like I mentioned before. And it's designed with 5 grades of detection sensitivities for different requirements. Here is the load parameters. We can set it here. New scripting project. Okay. The first step is to connect the device. Then enable the models. Choose script programming. Type in the example program as shown. And record point information by hand guiding. Save the program. Click to run and see how the robot moves. Basic motion commands. This table shows the basic motion commands description, like move J, drag move J, move L, jump, etc. I will talk about them in more detail. The first one is move J. It's a point-to-point motion, And the target point is Cartesian point. We need to set these parameters: CP value, speed, velocity rate, and acceleration rate here, and also CP value. CP value is the continuous path rate. It ranges from 0 to 100, and the velocity rate and acceleration rate ranges from 1 to 100. Move L means we want the robot to have a linear movement. We also need to set these parameters as the same as the last one. Joint move J is a little different because the target point is joint point. Here, its coordinates is under the joint coordinate system. So only joint point is supported. This command means we want the robot to move from one point to another in a door-like route. This command is often used for palletizing. The jump parameter can be set in this command. So we need to set the speed, velocity rate, acceleration rate, and lifting height, maximum lifting height, and dropping height. Arc means we wanted to move in an arc movement. So we need to set 2 points, the middle point and the end point. Both of them are user-defined, or we can obtain them from the points list. And only Cartesian point is supported. We also need to set acceleration rate and velocity rate and the CP value. This is a circle movement. This command needs to combine with other motion commands to obtain the starting point of a circle trajectory. So we need to set 2 middle point, which is also user-defined, or we can obtain them from the points list. And we also need to set the count, the number of the circles. We can get different radians by setting different values. In the picture on the right, we set the CP value for 0, so its motion will be a quarter turn. And when we set it 100, it's much smoother. These are some command optional parameters. Like I mentioned before, these two, speed and acceleration is ranges from 1 to 100, and speed is the proportion of motion speed. Acceleration is the proportion of motion acceleration. The CP value is the smooth transition. We can set the smooth transition during motion, and it ranges from 0 to 100. The acceleration affects how fast the speed changes. Speed L, acceleration L should be used when commands are move L, jump, arc, circle, remove L, etc. While speed J, acceleration J should be used when commands are move J, joint move J, remove J, etc. Now, I would like to move on to the basic programming control commands. The looping types we mainly use in robot programming are while, for, and repeat until loop. So let's see how these loops are used. This is the while command. When the condition is true, the program has been looped. So it means that if the DI is on, the first pin is on, the robot will move to the point 1, point 2, and point 3. And if the condition is not met, the input signal is off, then it will print hello world. Since the script is usually running much faster than the robot, we need to add a synchronization instruction to make them run synchronously. That being said, for example, in this example, if we don't have this sync instruction, it means that it may print the value of I before running at point 3. Okay. How to use I/O. This is I/O interface. Sorry for that. Okay. The output current of each I/O cannot exceed 500 milliampere, and the overall current cannot exceed 2 ampere. There are 3 interfaces on the forearm. The second one is AND effector, which can be used to connect external devices. This picture shows each pin of the AND effector. Here is a video that shows the usage of I/O. Okay. This is some pictures of each device. The vacuum suction cap kit, sofa grippers, electromagnet grippers, soft grippers, and vacuum pump box. In our software, we can control the AI here. Each pin, we can select each DO and DI we want. Now we are going to take a 15-minute break. And during the break, if you have any questions, you could type in the chat window and Hans will answer it as soon as possible. Okay, let's move on. So by using the follower instructions I just mentioned, we can complete a rectangle and triangle and a circle. Yeah. Now I would like to move on to the next part, palletizing. Palletizing is an important application of MG400. To complete the palletizing, we need to know the following three parts. How to use the section cap. By using the section cap, the object will be picked up after the end of the robot moves over it. And that's the function of the section cap kit. This is a vacuum section cap kit and a pump box. First, we need to assemble these two widgets as shown in the picture and attach them to the end of the robot arm. And then we need to connect the vacuum pump box. Connect cables as shown in the figure. There are four interfaces: ground, voltage, pressure, and vacuum. Okay. When the robot is installed with the end effector, especially off-axis or multiple end effector, a torque coordinate system can be established to define the virtual Cartesian coordinate system with the end effector TCP position as the origin to improve the efficiency of point teaching, programming, and end effector switching. And by setting the user coordinate system, the users can define the origin and direction, which is convenient and efficient. This is the interface of our software. In the menu, we can change the coordinate system and select one, then click Modify. This picture shows the default user coordinate system. We need to set 2 points in this coordinate system. The first point is the origin, and the second one is in the direction of the positive x-axis. The first one is the origin here, and this is the second one. we can select one of the tour system. Here in the coordinate system, tour frame, and select any one we want. So by setting these 2 points, we can create the corresponding tour coordinate system. The first point is the origin, and the second one is the posture, which means that the robot rotates around the origin, like this. Okay, this leads me to the next point, which is creating a new palletizing process. Okay. Here, 6 objects are placed in this area, 3 rows and 2 columns. And we want to stack the object in 2 layers and 1 column, 2 layers. This is demo which we can use for palletizing process. The red commands illustrate the functionality of the main code. In addition to scripting, we can also use graphical programming to accomplish this project. Okay, how about we watch a video to learn how to create a palletizing project? This is the code we just mentioned here. And then set the number of rows and columns we want here. And Z means the layers. And the point coordinates value. The first point is the first picking point. We can manually obtain it. And the second point is the second picking point next to point 1 in the positive direction. Like I just said. We can also manually obtain it after pressing the hand touch button. We can drag it to any point we want, and it will record the value of the coordinates. And remember to set the value of R to 0. This is the height of the object. And it also has prepare point and save point. Prepare point is the previous point at which our robot grabs the object. Is the save point. I made a mistake. The save point is the previous point at which our robot grabs the object. And after the setting of picking process, let's look at how to place them. Basically, just like we did before, we need to manually move the robot get the coordinates of each point where the object is to be placed. Also set the value of R to 0. After setting, click Start. Let's see how the robot moves. Okay, that finished. Now I would like to move on to the next part, remote control. Open our software and click remote control. As we can see, there are a few ways to control the robot. Online, remote I/O, remote Modbus, and TCP/IP. The first one and the first and second one, we can control it. Click online so we can control the robot in this software. Click the second one, we can control the robot without PC after we finish the corresponding program. And the last two are Modbus TCP and TCP/IP, which can also control it without PC. We can set the values of different pins to achieve different corresponding functions. This is the description of each pins, DI and DO. We can check it later and set it here. So next one, we change the current mode to remote Modbus, and these are the description of the function of each core register and discrete input register. And it should be emphasized that when a remote Modbus, the robot is the server and the external equipment is the client. The IP address is 192.168.1.6 and the port is 502, which cannot be modified. This is Modbus simulation software. Here it's little tiny. Select the reading function. Here is the reading function and click OK. Then it will show the state of each discrete input register here. Let me introduce you to some basic settings. In our software, click menu, there are some basic settings we can change, and we can also see the specification of our robot. If you have any technical problem or question, please don't hesitate to connect us. And it would be better if you could provide a screenshot shows these specifications, such as software version number, the controller firmware, server, SN, etc. It will help us to improve our efficient. Happy settings. So in the menu, in the settings, find the communication settings, we can see this IP settings. And the custom modification of LAN to IP address cannot be modified to 192.168.1.6, which is the IP address of LAN 1. And it also cannot be modified to 9.1. Let's talk about firmware update. In here and open the controller firmware we send you, then click update. We will complete the update. Okay, when the robot is collided or the coordinates are found to be inaccurate, we need to do the home calibration. Click home calibration and input the password. Here shows the interface. It should be emphasized that home calibration is only used when the home position changes, so we'd better operate it carefully. This is a calibration stick which can help us to move the device to home position. So put it here. This is joint 1. Put it as the picture shown. And this is the joint 2. Joint 3. And when this 4 joints value becomes 0, we could click this button. We have to make sure that we move the device to the home position and then click here. Okay, that brings me to the end of my presentation. Thank you for your attention. If you have any questions or suggestions, please feel free to say it. It's our pleasure to have your feedback. Please, if you have any questions. If you have any questions, you can type in the chat window and okay, can I provide PowerPoint? Yes, sure. We will provide it to you by email. Or if you have any further questions, please don't hesitate to send us by email. Send it by email, and we will reply to you as soon as possible. And you can also unmute yourself to ask if you want. And it would be better if you could comment on this training. If you think it's good, type good in the chat area. It's important to us. Thank you. Thank you. Okay. For this question, can we customize safe skin technology? Currently, this operation is not supported, and we will communicate with research and design department to see if it's possible in the future. If you think this is a good training session, please type good in the chat area. It's really important to me. Thank you, Ken. Thank you, Alfred. Thank you, Monica and Dan. Thank you, Hans. Thank you, Harris. Okay.